All right, let's jump right in. Today we're talking about something that has completely, and I mean completely, changed our world. Big data. You hear the term thrown around all the time, but it really is this revolutionary force, this digital tidal wave that's washing over everything. So let's get into it and figure out just how big actually is.
Get this. Every single day, all of us together, we create 2.5 quintillion bytes of data. Now, that number is so huge, it's almost meaningless, right? So let's try to picture it. If every one of those bytes was a gallon of water, you'd have enough to cover the entire state of Texas almost 2 feet deep. And that's not once, that's every single day. I mean, the scale is just insane, and it created one of the biggest tech challenges of our time.
So, what exactly is big data? Well, the official definition is pretty much what you'd expect. It's any pile of data that's just too big, or moving too fast, or is way too complex for our old-school tools to handle. Think of it like this. Our traditional software was like trying to empty that Texas-sized flood with a teaspoon. It just wasn't going to happen. The tools we had simply broke under the pressure.
To really get a grip on the problem, you've got to look at its 4 main ingredients, what people call the 4 V's. First, you have volume. That's the mind-numbing scale of it all. Think every single credit card swipe in one day all over the world. But it's not just big, it's coming in hot. That's velocity. The data is being born at an incredible rate, like the constant non-stop waterfall of posts on social media. Then there's variety. This isn't your grandpa's neat and tidy spreadsheet. No, this is a chaotic mess of text, pictures, videos, sensor logs, you name it. And just to make it extra fun, you've got veracity, which is a fancy way of asking, is any of this messy, high-speed data even accurate? Put them all together, and you've got a perfect storm.
So this all leads to a really fundamental, almost philosophical question, doesn't it? How in the world do you store something that's literally bigger than any single container you have? This was the first giant monster that needed to be tamed. And the solution was, well, kind of brilliant.
The answer is something called a distributed file system, or DFS. You might have heard of Hadoop's HDFS. That's the most famous one. The idea is so simple, it's genius. If you can't fit the file on one computer, just don't. Instead, you spread it out across a whole bunch of them.
And here's how it works. It's a 2-part punch. First, you distribute. You take that gigantic file, chop it up into smaller, more manageable pieces, and you scatter those pieces across a whole network of cheap, off-the-shelf computers. But you might be thinking, what happens if one of those computers just dies? That's where the second part, replication, comes in. The system is smart enough to make multiple copies of each little piece and store them on different machines. So if one computer kicks the bucket, no big deal. The data is safe. Problem solved.
Okay, cool. So we've figured out how to store the data by spreading it all over the place. But wait a minute. In solving one problem, we've just created a brand new one, haven't we? The data is now sprinkled across hundreds, maybe thousands of different machines. How on earth do you analyze it without spending the next decade just trying to pull it all back together? And that brings us to the next stroke of genius, a programming model called MapReduce. It's an engine that was specifically designed to process data that's already spread out. It's the perfect partner for that distributed file system we just talked about.
And this right here is where the whole way we thought about computing got flipped on its head. See, the old way was to haul all the data to the code. You'd literally move mountains of information to one giant supercomputer. MapReduce does the exact opposite. It says, don't move the mountain of data, move the tiny shovel of code. You send your little program out to each computer where a piece of the data already lives. It's a total game changer. So much more efficient.
So how's it work? Okay, imagine you have to count every single word in a massive library. The old way is one person running around for years. The MapReduce way? In the map phase, you give every librarian a single shelf and tell them to count the words just on their shelf, all at the same time. In the shuffle phase, all those counts get sorted and grouped together by word. And finally, in the reduce phase, one head librarian just combines all the little totals to get the final grand total. It's a classic divide and conquer strategy, but for data.
Okay, so we've solved storage, we've solved processing. But let's rewind a bit to that third V, variety. How do we deal with all the messy stuff that doesn't fit into nice, clean rows and columns? We're talking tweets, images, server logs, all that unstructured chaos. This is where we needed a totally new kind of database. Enter NoSQL, which actually stands for Not Only SQL. See, traditional SQL databases are super rigid, like a spreadsheet. Every row has to have the exact same columns. But NoSQL databases are flexible, more like a folder full of documents. Each document can have its own unique structure, which is perfect for all that messy modern data. Plus, they scale out horizontally,
meaning you just add more cheap computers, which, hey, fits perfectly with this whole distributed model we've been talking about. So we've been way down in the technical weeds, right? We've talked about the how, the clever solutions for storing and processing this data monster. But the real question is, why? I mean, who cares about all this tech unless it actually does something? So let's look at how this stuff is actually reshaping the world around you and me.
Let's start with banking. Every single time you swipe your credit card, big data is whirring away in the background. It's analyzing millions of transactions a second, comparing your purchase to your normal habits. That's how it can flag a weird charge as fraud in milliseconds, sometimes before you've even put your card away. And beyond that, it lets banks really understand financial risk and customer behavior, which is why you get all those personalized offers.
Or think about your downtime. Every time you open up Spotify or Netflix, you're plugging into a massive big data engine. They aren't just guessing what you might like. They are analyzing the viewing habits of millions of people to predict, with scary accuracy, what song or show you'll want next. It's even changing live sports. At Wimbledon, they analyze player stats and fan comments in real time to make the broadcast more exciting for everyone watching at home.
And in healthcare, man, this is where the stakes get really high. By looking at huge sets of health and location data, scientists can now start to predict where a disease outbreak might happen next, so they can get ahead of it. It's letting doctors use evidence-based medicine, where your treatment can be guided by the outcomes of thousands of other patients just like you. It's a massive leap forward. Big data is even transforming the cities we live in. You know when your GPS app reroutes you around a traffic jam? Yep, that's big data, analyzing signals from thousands of phones and road sensors to find the best path right now. Police departments use it to find crime hotspots and decide where to put patrols. It's all part of this bigger idea of a smart city, where we use data to make city life safer and just, well, better. To really bring this all home, just listen to this quote from Google's Eric Schmidt back in 2010. He said, "There were 5 exabytes of information created by the entire world between the dawn of civilization and 2003. Now, that same amount is created every 2 days. Just let that sink in. The growth is exponential, and the tools we've been talking about are the only reason we're not completely drowning in it." So there you have it. We've tamed the data monster. We can store it, we can process it, we can find these incredible patterns inside it. But all this power brings up some really big new responsibilities, doesn't it? Questions about privacy, ethics, and what kind of world we're actually building. Now that we can analyze literally everything, what's the one question we should be asking? It's something to think about. Thanks for joining me on this explainer.